Now we're gonna move on to our calculator. Now we're not thinking about Boolean algebra. We're trying to add numbers now, right? So normally when we're adding numbers, we use regular numbers. So that go from like 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's gonna be in base 10. We have 10 digits from 0 to 9, and then each digit or placeholder is gonna be a factor of 10. So right. We have our ones place, our tens place, our hundreds place. Those are all factors of 10. Meanwhile, in binary, we have base 2, so we only have zeros and ones. But then each place is going to be representative of a factor of 2. So our first digit is still going to be 1 because that's going to be 2 to the 0. But every place afterwards is going to be representative of a factor of 2. So we're going to go from 2, 4, 8, 16, 32, so on and so forth. We can use binary to represent any number as well, with powers of 2. So when we're trying to add things, right? When we do decimal, we can just do, if we're trying to add 1 plus 1, we can just say 1 plus 1 is 2. We know that, right? But in binary, we don't have 2, right? So when we're doing 1 plus 1, it's technically 2, right? But we don't have that digit. So it's going to be kind of like when we do 9 plus 1, right? Our answer is going to have that digit is going to be a 0, and then we have a carry. We carry that 1 over here to the next place, which is going to be the 2's place, right? So then this is going to be our answer, which is equal to 2, right? 1's place is 0, so there's no 1's, and then we have 1 in the 2's place, so we have 1, 2, so 2 plus 0 is 2. Does that make sense to everyone? Okay. So when we're adding two one-digit binary numbers, right, we're going to have our results going to have 2 digits, right, because we can go up to values of 1 plus 1, which is going to be equal to 2. Right. So when we're making our calculators, right, we know intuitively that these are the answers, but when we're doing the outputs, right, computers and our logic, it's still either on and off. So we need to analyze the different placeholders as different equations, kind of. So we need to figure out a Boolean expression that would give us the answers in the 1's place as well as the 2's place, which we're going to be calling our sum and our carry for the to be carried to the next place. So how do we find a Boolean expression for these? It's basically we're going to try to, so for our case, we're just going to find patterns and common expressions we already know. So for a half adder, that's basically just going to be when we're adding 2 digits, and then we're getting 2 outputs, our sum, which is in the same place, and our carry, which is the one that goes to the next place. And so if we separate our carry and our sum and we look at those, we see that they're very similar to expressions we already know, which are our AND and our XOR, right? So 0 plus 0, we're just going to get zeros for both. 0 plus 1, we're just going to have 1 in the sum. 1 plus 0, same thing, but inverted, one of our properties again, sum. And then 1 plus 1 is 2, so 0 in the sum and carry is 1. Okay? And when we compare these end up being the same as these 2 expressions that we've already had a lot of practice with. So when we're building our calculators, we're actually going to be representing these inputs and outputs as these gates, with these gates. So we're going to be, right, so our AND is going to be representative of our carry, and then our XOR is going to be representative of our sum. So
yeah, they put them only on page 144.
So yeah, we have symbols for all of these different things. So not is going to be this triangle with the dot. And is this one. Or is a little curved. Yeah. So those are. So then say we're adding a 2-digit number, right? And so now we're going to analyze the second digit, so the 2's place, right? But so what if for our 1's place, we already had 1 and 1, we had that carry, right? So this is where the full adder comes in. So this is gonna be for all digits past the first digit, right? Because now for the other digits, they'll usually have a carry, either 1 or 0, depending on if the digit before that had excess. So the full adder is a little more complicated. You won't necessarily get the patterns right ahead. We've given it to you, so these are gonna be your inputs. So A, B, and C. C in from your last half adder from your ones place, and then your outputs are C out, which is gonna be the fours place, so our third digit, and then S, which is gonna be our sum, which is the second place. So just based on this diagram right here, can anyone figure out what the expression for S and C out would be? And you can kind of work it out on paper if that's easier. And just be careful. So the dots here, so I know there's a lot of overlap here. So dots are explicitly where things are connected. Overlaps like this aren't connected unless they have a dot explicitly placed on it. So you don't get confused around this area. So I guess we can try to go over this together. So, right? So what's this gate right here? XOR. Right. So this is going to be the XOR of A and B. Right? And then that goes into this other XOR gate. Right? So that's going to be XORed with what? What's the other input to that? Cn, yeah. So, and then that's going to give us S. So our expression for this is going to be parentheses A XOR B, and then that XORed to Cn.
Is that only one of the A, B, and C's would be a 1? Does that mean only one A, B, or C can be a 1, or S be a 1?
Yeah, so, right, we can see it here in this table. But, right, so if our first, so yes, but see, in this case, right, so if A and B are both 1, right, if those are, when those XOR, we get a 0. But when we XOR that with C in, that's going to come out a 1, right? So if we add 1 plus 1, we're going to get 2, which is, we can carry 1 digit. So say 1 plus 1 is 2, we can carry that out. But if we have 1 plus 1 plus 1, that's going to be a 3. So that carries out to 1, 2, right? So 1 to the next place, and then the 1, 1 that stays there. Kind of like when we add, say, like 9 plus 4, right? We keep 3 there and then carry 1 over still. We don't carry. That makes sense? Yeah. And then for C out, we have our inputs here, A going here, B going here. What's this gate? And, right. So we're going to do an AND of A and B. And then we're also going to have another AND gate. So that's going to be from A XOR B from the first one we did. That's going to be ANDed with C in. And then these two AND gates go together into an OR gate. Right, so it's going to be, you're going to have 2 parentheses, basically with the in-between of the plus sign for OR, with each parentheses having those equations. So A, B, so A and B, so A multiplied by B, and then parentheses A XOR B multiplied or ANDed by C in. That makes sense? So for our sum, that's going to be equal to A exclusive OR B, that first gate over there, and then that's going to be exclusive ORed to C in, right? Following the 2 gates up top, which lead to S, and then C out. Little more complicated. We have 2 main parts that are going to go through an OR expression together. So our first part is just going to be A and B. Our second part is going to take our result from that first gate, so A exclusive OR B. it's going to be ANDed with C in. Okay. Is everyone kind of clear on how we kind of got that from the diagram to the equation? Okay. And so if we want to kind of confirm that, so last table, I think it's in your book, right under the picture for the full adder. So this is kind of just verifying the equations that we got already for our sum and our C out. So we can go through, I'll give you a few minutes to kind of go through that and just kind of verify for yourselves.